This is the harbor of Ushuaia, Argentina, the edge of the inhabited world. In April 2026, a luxury cruise ship departed from these docks, carrying 150 passengers and crew on a journey toward the remote islands of the South Atlantic. For the first few days, the trip followed the standard rhythm of a high-end cruise. Passengers from 23 different countries socialized, attended parties, and enjoyed the isolation of the open sea, unaware of the biological threat already moving among them. 5 days in, a 70-year-old Dutch passenger reported to the infirmary with a fever and headache. It looked like a routine illness, perhaps some mild case of food poisoning or a common flu. But his condition collapsed with terrifying speed. Within days, his lungs began to fill with fluid, a process that prevents the body from absorbing oxygen. By April 11th, he had suffocated in his cabin. While the ship's crew managed the tragedy, the remaining passengers continued their vacation. They had no way of knowing that this single death was the opening act of a biological crisis. The pathogen didn't stay confined to the ship. When the vessel docked at St. Helena, the victim's wife disembarked to return home. Just as she reached the airport in South Africa, she collapsed and died before she could board her flight. Back on the ship, the sickness took another victim. A healthy German woman fell ill and died just 4 days later, confirming that whatever was killing the passengers was still active and moving. This logo represents the global authority that finally intervened. The World Health Organization conducted immediate tests on the crew and passengers, returning a diagnosis that should have been biologically impossible in this setting: Hantavirus. This is a virus with a 50% mortality rate. There is no vaccine and no established antiviral treatment. If you are infected, your survival depends entirely on your own immune system and basic supportive care from doctors. Medical experts were baffled because hantavirus follows a very specific transmission path. As this diagram shows, the virus traditionally jumps from rodents to humans. It is not known to spread through human contact, as indicated by the red X. On a luxury cruise ship in the middle of the ocean, there were no rats to interact with. The biological chain was broken, yet people were dying as if they were living in a rodent-infested warehouse. Scientists looked to history for an explanation, starting with the 1950s Korean War. Over 3,000 soldiers were incapacitated by a mysterious fever that caused their kidneys to fail, an outbreak so sudden that some feared it was a secret weapon. It took 30 years of research to find the source. A South Korean virologist eventually isolated the virus in local rodents and named it Hantavirus, after the Hanta River where the soldiers had been stationed. In 1993, the virus appeared in this arid landscape of the American Southwest. Healthy members of the Navajo Nation began dying of sudden respiratory failure, forcing researchers to look for an environmental trigger. This warning sign for El Niño explains the surge. Heavy rains hit the region, leading to a massive surplus of pine nuts. This abundance of food caused the local deer mouse population to explode. With millions of extra rodents, human homes and storage units became flooded with droppings and urine. When the waste dried, the virus became aerosolized. Anyone sweeping a floor or moving a box inhaled the virus directly into their lungs. These cases established the ironclad rule of hantavirus. It requires a massive environmental surge and direct proximity to rodent waste. This made the outbreak on a sanitized modern cruise ship appear to be a medical anomaly. A 1996 outbreak in southern Argentina identified a specific viral mutation that changed the medical profile of the disease. This taxonomical tree shows the different families of the virus. The branch glowing red is the Andes strain, the only variant ever documented with the ability to transmit directly from one human to another. Even with this mutation, the virus is limited. It requires very close physical contact, and as this clock illustrates, the infectious window is extremely narrow. An infected person can only pass it to others for about 1 day at the very start of their symptoms. The cruise ship mystery was solved when investigators looked at the movements of the Dutch couple. Just hours before boarding, they had visited a landfill in Ushuaia on a birdwatching tour, a location heavily populated by wild rodents. They inhaled the virus at the landfill and boarded the ship exactly as their 1-day infectious window began. Because they were in the enclosed, high-density environment of a cruise ship, the Andes strain was able to jump to the other passengers. This aerial shot of Tenerife marks where the ship was finally allowed to dock. The deaths on board were caused by this rare viral mutation, meeting the realities of modern tourism in a tragic, perfectly timed collision. This split-screen comparison shows why Hantavirus is not the next global pandemic. Unlike the viruses on the left that float through the air, the Andes strain on the right requires prolonged, close physical contact, making it much harder to sustain a massive outbreak. While global risk is low, the 50% mortality rate makes every local outbreak a serious threat. As climate patterns like El Niño become more intense, we can expect more frequent surges in rodent populations, and consequently, more human infections. Protection begins with structural defense. Sealing gaps in your home and properly disposing of food waste breaks the attraction cycle. If rodents cannot enter your living space, the virus cannot reach you. In high-risk areas like old warehouses or sheds, N95 masks and gloves provide a physical barrier. These tools prevent you from inhaling the microscopic aerosolized particles found in dried rodent droppings. In the absence of a vaccine or a cure, awareness and prevention are the only effective shields. By breaking the environmental chain between rodents and our living spaces, we can stay safe from a virus that thrives on our